this will be physics course practice, starting with 3.19. Students are measuring how extension of a spring varies with the force applied to it. The results are summarized in the table below. We only took one law that has anything to do with springs, and it's Hooke's law. I just need to memorize one law. And then the spring constant, we took that F equals delta L K. They want the spring constant K. Delta L is the extension, and you need to convert it in meters. So 40 millimeters divided by 100 to convert to meter, not 100, divided by 1000, you get 0.04, and you have the force. So 10 newtons equals to delta L 0.04, and K we're gonna put it X. 10 over 0.04 equals X. You put it in your calculator and you get 250 equals X. Again, the only thing in this section is Hooke's law. He has a spring, unstretched is 5 centimeters, the weight 20 newtons, and its length becomes 15 centimeters. So to find the extension, we do length final minus length initial equals delta L. So 15 minus 5 is 10 centimeters. We want it in meters, so we divide by 100, and it's 0.1 meters. So we do F equals delta L K. They want the spring constant. Delta L is 0.1, the F is 20, and K we're gonna put it X. 20 over 0.1 equals X, and you get 200 equals X. Again, for this question, Hooke's law, they gave us the graph. F equals delta L K. We get a point to 0.042. Here the extension is already in meters, so no need to convert anything. F is 2, delta L is 0.04, and K 2 over 0.04. You put it in your calculator, you get 50 equals K. Don't forget the units if it's written. Now 3.20, this quiz, you just have to memorize definitions, that's it. It's 2 questions and they're the same. You just have to memorize the definitions. Strength is large force to break them. Strength, the definition. Stiffness, it cannot stretch or bend. Elasticity, it can stretch and bend and go back to its original size. Plasticity, property stays permanently deformed like plastic. It's literally in the name. Ductility, mainly it's being able to spread into very thin sheets and wires. And brittleness, it breaks suddenly. Question 2, it's the same thing. Stays permanently deformed, plastic. Very thin wires, ductile. Breaks suddenly, brittle. And does not stretch, is stiff. There isn't a quiz for 3.21, so this is 3.22. We've been having this for CA for the past 2 weeks, I think. So, 2 particles, A and B, of masses 60 and 40 grams are moving towards each other with speed 5. So, 60 grams, in physics, anything we convert it into kilograms. So, divide by 1000, and divide by 1000. You get 0.6 and 0.4. So, we use the equation m1 v1 plus m2 v2 equals v m1 plus m2. m1 is 0.6 times v1 is 5. Now they're moving towards each other, so we'll take particle A as the positive and particle B is the negative. Plus m2 0.4 times v2 minus 5. we're gonna name it x, m1 0.6 and m plus m2 0.4. 0.6 times 5 0.3 plus minus 0.2 equals x times 0.1. So 0.1 equals 0.1x. You move it to the other side, 0.1 over 0.1 equals 1, and it equals x. So the speed is 1. If they ask for significant figures, it's also 1, because 5 is the least significant figures. And since they're moving with the same speed, and A is the heavier, so it's going to continue in the motion in the direction of particle A. Here the question is two-part. Cart A is mass 4 and speed 3, and stationary cart B, so 0 meters per second. The collision, the carts move in opposite directions with a speed of 1 meters per second. The initial direction of motion, okay. And they also tell us that the direction of cart A is the positive direction. First part, they're asking for the momentum of cart A. So P momentum is mv. M is 4 and V is 3. So it's 12. And then momentum of, and then they want the mass of cart B. So m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. m1 v1 we already got it, 12, plus m2 v2, m is x, v2 is 0, stationary. m1 v1 prime, m1 is 4. Now look, they said it moves here with speed 3, and this is stationary, and then they move in opposite directions. So this one moves, cart A moves in the negative direction, and then cart B moves in the positive direction. So v1 prime, they move with a speed of 1, so negative 1, plus m2 v2, m2 is x, and v2 is positive 1. So 12 equals minus 4 plus x. You move it to the other side, and 16 is equal to x. Here trolley A is mass of 3 and trolley B is 2 kilograms. Just before collision, trolley A has a speed of 5. So they want the magnitude of momentum just before collision, so 3 times 15. P is mv, m is 3, v is 5, so 15. And the magnitude of trolley B, the magnitude of trolley B's momentum, speed was 0 because it's stationary, so it's mv, v is 0, so it's 0. 2 times 0 is 0. Now they want the magnitude of the momentum for the combined trolleys after the collision. Now see, this is here was before the collision, and now they want after. So using the law of conservation of momentum, P before equals to P after. Before it was 15 plus 0 is 15, and after it's equal to before, so 15. Then they're asking for the combined speed of the trolleys, so combined speed, so they stick together, and m1 v1 plus m2 v2 is equal to v final m1 plus m2. m1 of the cart A is 3 and cart B is 2, so 5. vf we're gonna say x, and m1 v1 is the total momentum before, m1 v1 plus m2 v2 is the total momentum. We got it 15. So 15 divided by 5, 3. So 3 equals x. Then for the last part, they said instead of sticking together, trolley A moves with velocity 2 in the same direction, so it stays positive. So m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. We already know that this part is 15. m1 of the cart is 3, cart A is 3, and velocity 2 they said, m2 is 2, and v2 we're gonna say x. So 15 equals 6 plus 2x. You move it to the other side, so 15 minus 6 equals 2x. 9 equals 2x, and you divide by 2 on both sides for 4.5 equals x. A 15 grams bullet is fired from a 5 kilograms rifle with a speed of 500 meters per second. So they want the initial momentum. So the whole thing was stationary, so the momentum is 0. The whole thing is stationary in the beginning, so momentum is 0. And then the recoil speed, m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. So this whole part is the initial momentum. It's 0 equals m1. We're gonna do m1 is the bullet. 15 grams, you convert it into kilograms divided by 1000, so 0.015 kilograms. 0.015 times 500 plus m2 is 5, and v2 we're gonna say x. So 0, you put it in your calculator, 0.015 times 500, you get 7.5 equal plus 5x. You move it to the other side, minus 7.5 equals 5x, and then you divide by 5 for, you get 1.5 minus 1.5 equals x. You would put minus 1.5 if they ask for velocity, but they said speed is scalar, so 1.5 is v2. They say here a 2 kilograms trolley is subjected to a constant horizontal force of magnitude 10 newtons for 3 seconds, and they want the velocity after 3 seconds. Now we know that momentum p is equal to impulse j, so p is mv and j is ft. Mass, we said it's 2 kilograms times velocity x, so 2x equals force 10 and time is 3. So 2x equals 30, you divide by 2, and x equals 15. So the final speed is 15. A 1500 kilogram car is moving to the right with a speed of 20 meters per second when it collides with the wall and rebounds with a speed of 5. When they say rebound, it means that the velocity is negative, so negative 5. If the collision lasts for 250 milliseconds, you divide by 1000 to get seconds, so 0.25 seconds. Then the magnitude of the average force acting on the car is. So now you want the force, also P equals J. Now P here, they said the rebound, so mass equals mass times delta V equals J is F times T. Delta V 20 minus 5. They said rebound, so it's the velocity is negative and the mass is 1500. So 1500 times 25 equals force x times times the time 0.25 seconds. So 1500 times 25 is 37500 equals 0.25x. You divide by 0.25 and x is equal to 150,000. They want the answer in kilonewtons, so you divide by 1000 and you get 150. For this part, in an isolated system, the total momentum of the two objects before the collision is blank to the total momentum. Law of conservation of momentum, momentum before equals to momentum after. You just have to memorize this. And they want the speed of the gun, so the mass of the gun is 0.5 and the mass of the bullet is 0.009. Okay, so before the whole system was stationary, so the initial momentum is 0, and m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. So m1 for the mass of the gun 0.5, and v1 we're gonna say x, plus m2 0.009 for the bullet, times velocity, it's 300 meters per second. So 0 equals 0.5 plus 0.009 times 300, you get 2.7. You move it to the other side, minus 2.7 equals 0.5x. You divide by 0.5, you get minus 5.4 equals x. They said speed, so you don't have to put a sign, so 5.4 meters per second. Here they're asking for momentum, P equals mv, m is 0.009 times v 380. So 0.009 times 380. You put it in your calculator, whatever you want to do. So P equals 3.42. They also accept 3.4 or 3.42, but the answer is 3.42. Here they did it in significant figures. Significant figures, least significant figures, 0.0090, only 290. We have a ball of mass 0.2 moving leftwards, so moving at speed of 5 and stationary towards a stationary ball of mass 0.3 kilograms. So m1 v1 plus m2 v2. They said upon collision the balls stick together. So v final m1 plus m2. m1 v1 0.2 times 5 and m2 v2. The first mass is 0.3 and it is stationary, so 0. And vf, we're gonna say x. m1 plus m2, m1 is 0.2 plus 0.3. You get 0.5x equals 0.1 plus 0. So 0.1 divided by 0.5 equals x. We just simplify and move around, so wait, sorry, my bad. It's 0.2, I did a calculation mistake. 0.2 times 5 is 1, not 0.1. So you get 1 plus 0 is 1 and equals 0.5. You divide 0.5, you divide by 0.5 on both sides. You get 1 over 0.5 equals x, so 2 equals x. Here they're asking for the impulse of ball 200 grams, so divide by 1000 to get kilograms, 0.2, and speed 3, and bounces back, so so velocity minus 2.5. P momentum equals J impulse. They want the impulse, so J equals P, and P here is mass, so 0. There's the equation mass times delta V is momentum, so mass delta V is 3 minus 2.5, so 5.5 m x. We're gonna call mass x equals J, and sorry, not x, the mass is 0.2, so times 0.2 you get 1.1. Impulse J equals Ft. F is 500 times T 0.16. Put it in your calculator. You get X is 80, or J, or whatever you want to call it. Here they're asking for the unit for linear momentum. Don't need anything. Mass times V, mass is in kilograms, times velocity meters per second. Kilograms times meter per second. A car is moving uniformly to the left on the straight horizontal road. What is the direction of its momentum? Direction. You don't need anything to do this. To the left, so the direction to the left. If you can't solve this, I don't know what to tell you. بس يعني grade 2 could solve it. And last question in this quiz, the law of conservation of momentum. You need to memorize this. When objects interact, the collision or explosion, the total momentum of the object remains constant. It always remains the same if no external force is acting on them. This is 3.23, last quiz in chapter 3. This whole quiz, it's only one question, and it's based on Newton's third law. For every action, there is an equal and opposite reaction. So a rotating bicycle pushes the earth backward. Just make it the opposite, so the earth pushes the bicycle forward instead. So the bicycle, imagine this is a wheel. It pushes backwards, so the earth itself is pushing forwards. A human is moving by pushing backwards, so the ground pushes forward. The boat pushes the water backwards, so the water pushes the boat forward. The rocket engine pushes the gases downwards, so the gases push the rocket upwards.